Alright, today we're going to be talking about binomial radical expressions uh, and also doing things like adding and subtracting radicals. So actually we do add subtract radicals first here. So when you are combining radical expressions and you have the sums and differences, what you essentially do is you take these outside things and you add them up together right there. And then inside the radical stays the exact same. And the reason being, it's kind of like this here. If you use algebraic expressions, for example, if you had like 5x and then plus 2x, we combine the coefficients out here. We say that's 7, and then we keep it as x. We don't change it to x squared or anything. So basically, it's like combining like terms. So combining like terms right there. That's the big thing that we're going to be doing here. Now you can only add like terms, or in this case, like radicals. Okay, and then when adding or subtracting radicals, add and subtract their coefficients, and then leave the stuff inside the radical the same. So for example, if we have something like this, if we got 5 square root of 2 plus 4 square root of 2, we're going to add these two numbers here, and this will be 9, and then this stays this square root of 2. So when adding and subtracting, nothing changes inside the radical. If you got something like this, you got 3 square root of 5x, and then negative 2 minus, or negative 2 square root of 5x. Subtract those right there, that'll be 1, and then square root of 5x. Most of the times, you'll just see people just write square root of 5x. There's already an implied 1 out in front. Okay, this next one here, since you have different indexes right here, these are not the same radical here, so you can't add these. So this is actually fully simplified. Can't do much with that. Alright, let's see what's going on here with this one. You got xy, so that's good to go as far as adding. So I guess we're going to add 4x and 3x. If we add 4x and 3x, you get 7x. This will be 7x and then square root of xy. Okay. Alright, next one here. This one's kind of a special case here. Some of you guys might be saying, well, we can't add these here the way they are, which is true. So what we actually do with these here is if we can simplify them, maybe they will have like radicals. So we're going to take both of these here and use your factor trees. So things that multiply to 12, you got 4 and 3, 2 and 2, and then I guess we got 3 and 25, and then 5 and 5 here. So this first one becomes 2 radical 3. The second thing is going to become 5 radical 3. And then I guess we're going to subtract off a 1 radical 3 right there. And then now these are like terms. So now we can go ahead and simplify these. 2 plus 5 and then minus 1 essentially. That's going to be 6. 6 square root of 3. And then that is how you do that problem. So you must simplify down your radicals before these are combinable. Okay. Next one here is kind of the same idea, except we're dealing with some cube roots. So we need to be looking for groups of 3 things instead of 2. So I guess this one here, this is 25 and 10. I guess 10 you can go 5 and 2. 25 you can go 5 and 5. And then there's a group of 3 things there. This will be 5 and then cube root of 2 right there. Okay. Let's see what's going on with this next one here, 54. I guess you could go 9 and 6. 9 you can go 3 and 3. 6 you can go 3 and 2. So this will be plus 3 and then cube root of 2. And I guess we got this last one here, 16. Break that down, you can go 4 and 4, and then 2, 2, 2, 2. And then you got one group of 2's right there. So that'll be 2 and then cube root of 2 left over. Alright, and then you got like radicals going on here, so that's good. So 5 plus 3 is 8. 8 minus 2 is 6. So this will be 6. And then it'll do the cube root of 2. And then that is it there. So that's adding and subtracting radicals. There's really not any more variation you could have. I guess maybe they could throw some variables in with the radicals with these as well, but you don't see a ton of those. So the second portion of our lesson here today is, and actually it's kind of heavy on this here, is multiplying and dividing with radicals here. And so this is a number here. Notice you got 4 and then plus 2 square root of 2 right there. So this is actually technically, it's two pieces, it's a binomial there. So when you got a binomial times another binomial, this is basically a FOIL problem. So we're going to FOIL first, outer, inner, last. So we'll go 4 times 5 right there, that'll be 20. We're going to go 4 times 4 square root of 2. So if you remember back to your multiplying rules, that's 4 times 4, that'll be 16, and then I guess we'll go 6 square root of 2 like that. Okay, you'll do your insides here, so that'll be 5 times 2, that'll be 10, and then square root of 2. And then for the final thing here, you'll go 2, and then times square root of 4 right there. Square root of 2 times square root of 2 is square root of 4. Most of y'all might just simplify that down to regular 2 if you want. Now these middle terms here, since they both have the radical 2, you can actually add those. This will become, I guess, 26 square root of 2. And then you're going to have 2 times basically 2 right here, square root of 4. That's 2, so that's going to be 4. And then actually combine the 20 and the 4. So we'll say that this is 24 and then plus 26 square root of 2. Now be careful, that's all you can do there. I have a lot of students want to add these right here, but technically you need to multiply whatever these two are before you can add the 24 onto it, especially if you're trying to get the decimal there. So if you are leaving it in exact form, this is as much as you can do right here as far as simplifying goes. So that is it on that one. Let's try another one here with foiling 2 of these. So first times first, that'll be 6. Outside times outside, that'll be 4 times 3, so that'll be 12. And then square root of 5. Okay, your insides, 2 times 2 is going to be 4, so 4 square root of 5. And then this last set here, this will be 2 times 4 out in front, so that'll get you 8. And then square root of 5 times square root of 5 is square root of 25, which is a regular 5. Okay. Then I would combine your like terms here. Those are going to combine the 16 square root of 5. And then right here, 8 times 5, that's going to be 40 right there. So if that's 40, we're going to do 40 plus 6. That's going to get us 46. And then that is your answer fully simplified right there. So they're a little bit weird at first, but if you're very tedious, you shouldn't have any issues there. All right, the next thing we're going to do here is review what a conjugate is. A conjugate is just whenever you have a binomial and they have opposite signs. It's kind of like a difference of squares. And when this happens here, when you multiply them, it becomes a squared and then I guess minus b squared here. So essentially the middle terms, when you FOIL them out together, the middle terms will cancel out. And let's look at what that might look like with this one here, and then we're going to start using this little shortcut, I guess. So like if you do this one here, 6 times 6, obviously 36. And then 6 times square root of 12 is just 6 square root of 12. And then negative square root of 12 times 6, this will be negative, actually. And then 6 square root of 12. Notice you got the same thing there. And then square root of 12 times square root of 12 will be the square root of 144. But then that'll be just 12. And then also it'll be a minus here since it's a negative root times a positive root. So that'll be minus 12. Okay, and then the middle terms here actually cancel each other out since they're conjugates here. So this winds up being just 36 minus 12, which then I guess we can say is 24. So when you multiply conjugates together, especially conjugates dealing with square roots, the square roots actually are going to cancel out on these. And we're going to use that here in a second when we rationalize denominators down here. So let's try another one here. So if you want to use the shortcut for this, you can go and use this thing right up here, the fact that you have the difference of squares. So basically 3 times 3 is going to get you 9. Square root of 8 times square root of 8 is going to get you negative square root of 64, which is just going to be 8, right? And then simplify from there, that'll be just 1 once you're done there. Okay, now if you want to write out the full steps, you can go and get the 9 and then the negative square root, or what was it, negative 3 square root of 8, positive 3 square root of 8, and then minus the square root of 64. If you want to write out every step, you can. But the shortcut, if you recognize that they're conjugates, that will speed up the problems here on these significantly. So let's now talk about rationalizing the denominator here. To rationalize a function with sums or differences in the denominator, multiply the numerator and the denominator by the denominator's conjugate here. So I think on the 9.2 lesson we talked about rationalizing denominators. I think we did one like this here, where we multiply the top and bottom to make a perfect square, basically in the denominator. So it's kind of got similar ideas. We're going to multiply the top and bottom by something in the bottom here, except we use specifically the conjugate. That's the big thing. All right. So with this first example here, the conjugate would be the binomial of 3 plus square root of 6. So if we multiply the bottom by that conjugate right there, that will get rid of radicals in the denominator. Typically in math, we don't like the radicals in the denominator. Now whatever you do to the bottom of a fraction, you got to do to the top of the fraction as well. So we'll go ahead and FOIL the denominator together. And if you want to use a shortcut, you can. If you just want to go ahead and write it all the way out, you can. For this first example, write it all the way out. So this will be 3. This will be plus 3 square root of 6 minus 3 square root of 6. And then I guess minus square root of 36, which will be regular 6. Now up in the numerator, you only have one piece right here. So you're just going to take that one piece and I guess distribute it to both of those. So that'll get you, I guess, 12x and then plus, I guess, 4x square root of 6. Okay, next step is we're going to start simplifying. Since these were conjugates, the middle terms cancel out. And then you're just left with 3 minus 6. 3 minus 6, I guess we'll put negative 3 for that. And then I guess we have 12x and then plus 4x square root of 6. Okay. Now, sometimes you might be able to reduce some of the numbers. Honestly, you can split apart the fractions here. I think we did that a lot with the imaginary problems that were kind of similar to this. So we'd write, for example, 12x over negative 3, and then plus the fraction 4x root 6 over negative 3. So you can split apart the fractions. Sometimes they reduce nice, like this first one reduces to 4x, or negative 4x, but this other fraction does not. So I guess you could write it like this. You could write all over negative 3, or you could put a minus, I guess, out here in front instead of a plus, and then not have the negative 3. But yeah, one of these here will be a good answer. Honestly, any of those would be good there. So different modified version. I guess if the middle one here, probably not the best here. If you're going to split it apart, you might as well reduce it. So the first and last one there, good ways to write that answer. So there you go. If you multiply top and bottom by the conjugate, you get rid of radicals in the denominator. So let's try this one here. This will be 5 and then minus square root of 2. And then all over 5 minus square root of 2. Okay, so multiply the top and bottom by the same things, the conjugate there. So, and I'm going to do the shortcut this time. So 5 times 5 is going to be 25. The square root of 2 times the square root of 2 is going to be square root of, or negative square root of 2, or negative square root of 4, which will be negative 2. So there you go. There's the kind of the shortcut there. Let's be careful with this here when we're distributing. This will be 15 square root of 2, and then you'll have the square root of 2. Yeah, so this will be negative 3, and then times 2 right here. The square root of 2 times the square root of 2 is just regular 2. Okay, I guess all in the denominator here, where we can put 23. So we'll have 23, 15 root 2, that doesn't change much, and then I guess minus 6. And then that's one way you can leave your answer right there. If you want to split apart the fraction, guess you can do that, but I don't even think anything reduces. You can do minus and then 6 over 23, or you can put plus and then negative right there. It doesn't really matter which way there that you write it. So anyways, multiply by the conjugate. That gets rid of these crazy looking binomials in the denominator. So guess we got a couple more here. So do that here. This one here, they both have square roots, and that's fine. We're just going to multiply top and bottom by square root of 3, and then plus the square root of 5. And we'll just be careful when we're distributing. All right, the first two terms multiply together. Square root of 3 times square root of 3 is just going to be a regular 3. And the square root of 5, or the negative square root of 5 times the square root of 5 is just going to be minus regular 5. So I guess a negative 2. All right, and then we'll distribute this here. So this will be, I guess, 2 square root of 21. And then plus 2 square root of 35. And then from here, we can just write this all over, I guess, negative 2. And then actually, what's kind of nice about this one here is everything's divisible by negative 2. If you do all of these outside numbers here, divide them by negative 2 here, you're going to get negative 1 square root of 21. And then minus 1, I guess. And then square root of 35. And that would be the fully simplified version right there. The reason the signs are negative 1 here is because you're dividing by negative. A positive divided by a negative changes these numbers to negatives. Okay, let's do one more here. Another conjugate problem. Let's multiply by the binomial of 1 plus the square root of 3, opposite sign. Whatever you do to the denominator of a fraction, you need to do to the numerator. Right, so FOIL or use your shortcut in the denominator. 1 times 1 is 1. Square root of 3 times square root of 3 is, or negative square root of 3 times square root of 3 is just negative 3. And be careful, up there in the numerator, you can't use your shortcut because these are not conjugates. So be kind of careful here with these here. So we'll go 3 times 1 is 3. 3 times the square root of 3 is just 3 square root of 3. The insides, 1 times square root of 2 is 1 square root of 2. Whoops. And you don't need to write the 1. And then square root of 2 times square root of 3 is going to be square root of 6. Okay. Down in the denominator, we'll simplify that to negative 2. We'll combine our like terms right here. So this will be 3, and I guess plus 4 square root of 2. Or actually, you know what? We can't even add those there because they're not like radicals there. So actually, I guess with this one here, you can't really do much as far as simplifying. You know, some people might, ask, what can we do, as far as the order of the radicals, does it necessarily matter? I don't really think it does. I mean, I guess you could go in numerical order if you wanted. But I guess we're gonna leave it like that right there. And looks like that is it here for today. Kind of a shorter one.